And welcome, ladies and gentlemen. Let's go ahead and take a moment. Chapter 5, Lesson 12, wrapping up Chapter 5. And today we're going to use equations to solve word problems. Now, let's pause for a second. Take out your assignments 13 and 14 from before Thanksgiving break. Go ahead and pause, check assignment 13, and come on back when you're ready. And make sure you put a big old star, question mark, or circle any problem you're going to need help with. You know I'll be here to help you right before the test. And let's go ahead and take a look at assignment 14 now. Do the same thing, pause, and come on back when you're ready. So for today, the good news is not a whole lot new. Now, I'm not going to tell you it's easy, but you do have these skills because we've already learned two-step equations, multi-step equations like the red. Today, we're going to use multi-step equations with like terms to solve word problems. Eventually, we will be moving toward multi-step equations with variables on both sides, but we're not there yet. So if you wish, go ahead and pause, read this on your own, come on back when you're ready. I'm going to go ahead and read it together with you. There are a bunch of audio learners out there, learn better with hearing. Jose has 28 less pumpkins in his patch than Karen has in hers. Together they have 286 pumpkins. How many pumpkins does Karen have? Well, the first thing I'm going to do is grab my pen. And I'm going to go back and I want to say, okay, Jose's got some pumpkins. It seems like Karen has more, and together they have a bunch of pumpkins. Just be able to retell the problem without using any numbers. Now, how many pumpkins does Karen have is the question. Meanwhile, Jose has 28 less pumpkins than Karen. Together is a key math word, 286 pumpkins. So you'll see that I circle my numbers and the units, what they mean. Underline key math terms, less than, together, and then I box in the question. So I'm going to ask a very simple question. What is it that we want to know? How many pumpkins does Karen have? So I'm going to let K mean the number of pumpkins that Karen has. All right, so if we know that Karen has K pumpkins, what do we know about Jose? Here we go, 28 less than Karen. Now be careful with the order. It says 28 less than, but 28 less than what? So for Jose, we're going to start with Karen's pumpkins minus 28. Now we go for that final equation. If they're all together means if we add Jose and Karen together, it will equal 286 in the end. So what do we know about Jose? K minus 28. What do we know about Karen? K. And I think, folks, that is the toughest part of the problem. Taking the verbal sentence and turning it into an algebraic sentence, taking the words and making it into the math. From here, we can pretty quickly see that we have some like terms that can be simplified on that left side. If it helps, you're welcome to write in a 1. Totally up to you. So if we put the k's together, we'll find quickly that we have 2 k's. Subtract 28 equals 286. And now some of you are ready to start flying, aren't you? So first, if our final goal is to get what is k equal to, we got to get rid of the 2 and the 28. But we're going to get rid of that 28 first. That has nothing to do with Karen's pumpkins. So how do we get rid of that minus 28? We're going to add 28. And of course, we will be fair to both sides, because 28 and negative 28 cancel out. That leaves us with 2 k's on one side. Let's add 28 to both sides. But of course, we don't want to know what twice Karen's pumpkins are, so we can divide into 2 parts. 2k's split into 2 parts is 1k. No, you don't have to write the 1. 314 split into two parts is 157. And so we have simply answered the question, 157 pumpkins. Now, if you wish, you may come off to the side and check, but a couple things. First of all, I will note the directions for tonight's assignment. Do not say solve and check. Secondly, if your original equation is incorrect, sure, you can put in 157. Substituting in 157, you can then ask yourself, is this a correct number? And when you do that, it will ring true. But again, I will emphasize that is only if, well, even if your equation is wrong, it's going to look true because you're not starting with the correct equation. So if you recall from the last chapter in the test, several of you, I pointed out you must use the original equation. Well, we were not given an original equation. We had to come up with it. So I will not ask you today to check, but you're always welcome to do so. To repeat myself a third time, if your original equation is wrong, you'll never know it. It'll look true, but it's not going to work. So that's what I have, ladies and gents. If you wish, go ahead and get out a piece of paper and start your assignment early. Otherwise, I will start this in class. Thanks so much, and let's grow.